Here we go. Take 37. Trig ratios continued. What we're going to do today is we're going to solve sides of triangles. Okay? So solving sides of triangles using trig. Trigonometry. Okay? Anytime we do trigonometry, we always remember our good friend SOHCAHTOA. Just going to write him down. Oops. SOHCAHTOA. All right? So inside, let's get some examples going. How are we going to use trigonometry to actually solve for sides of angles? So example 1 says solve for x. And we want to round to the nearest thousandth. Thousandth. That is 3 decimal places. All right? So, given a triangle, we have to use trig with a triangle. And not just any triangle, has to be a right triangle. Just like Pythagorean theorem has to be used with a right triangle, trigonometry has to be used with a right triangle. All right? I got one side is x. I'm going to solve for that. All I know is the hypotenuse is 11. Now, with this, I've got a 41-degree angle. All right? Now, I don't know how to solve this because this is not a special right triangle. If it was 45, I could use special right triangles to solve this. But 41 degrees, it's not special right triangles. But I can use trigonometry. All right? One of the most important things is to put us at the angle that we have. Okay? Whatever angle was given to us, that's where we put ourselves. That's our reference angle. Okay? And I'm going to always come back to SOHCAHTOA. Remember that one. Okay? So looking at the angle that I'm given, 41 degrees, I need to recognize what sides do I know. Well, I know my x is the opposite of my angle. And my 11 is my hypotenuse, always. So I need to identify what uses my opposite and hypotenuse side. Looking at SOHCAHTOA, the O and the H falls with the S. The S stands for sine. So I remind myself here that sine is opposite over hypotenuse. So I can use that then to solve for the value of x. Okay? Now the way we do that, if I'm talking about the sine of the angle, so sine of 41 degrees is going to be equal to the opposite over hypotenuse is represented by x over 11. Okay? The way I solve for x is I simply put the sine of 41 degrees over 1. When I do that, it does not change the sine of 41. It just simply makes it a ratio. And then when I have two ratios put next to each other, set equal to each other, I can solve that using cross multiplication. So nothing new there. All we have to do is cross multiply. When I cross multiply, 1 times x is just x. And then 11 times the sine of 41. Be careful how you write this. Okay? 11 times, I'm going to put the sine of 41 all in parentheses because the 41 cannot be detached from that sine. This is the sine of 41. It's not 41 by itself. It's not just sine. It's the sine of 41. So x is equal to 11 times the sine of 41. I can use my calculator and do that. Okay? So 11 and then sine of 41. Notice that it opens the parentheses there for you, so I closed it. 11 sine of 41 to the nearest thousandth is 7.217. 7.217 is the value of x. Okay? Hopefully you guys got that. Makes sense. Let's do one more. Here's my right triangle. My right triangle is sitting on the hypotenuse. Okay? One side is x, the other side is 15. And then I know this angle is 22 degrees. Okay? So in order to know what trig function I have to use here, I put myself at the angle, and I identify from the 22-degree angle, 15 is the side opposite that. I'll put an O there. And x is the side adjacent to that. Okay? When I know I have the opposite and the adjacent side with the x, I look at my SOHCAHTOA and find out which trig function I need. Well, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. I have the opposite and the adjacent, so I'm going to use tangent this time. okay, the tangent of the angle, 22 degrees, is equal to the opposite over hypotenuse, 15 over x. Okay, put the tangent of 22 over 1 and cross multiply. This time the x is in the denominator, so a couple steps, just be careful. Solve it the correct way you always solve proportions. Okay, x times tangent of 22. I'm going to put that tangent of 22 in parentheses, and then 1 times 15 is 15. In order to solve for x here, previously it was already solved for x, and I just had x by itself. This one, I have x times tangent of 22. So I'm going to divide by tangent of 22, and then divide by tangent of 22, just like I would solve any proportion. Okay, so those cross out, and I'm left with x is equal to 15 divided by tangent of 22. So I take 15 and then divide tangent of 22, close the parentheses, and I get 37.126. So x is equal to 37.126. Okay, those are my two examples. So I can use sine, cosine, or tangent anytime I'm solving for sides of a triangle. Make sure you guys complete the WSQ. I have an example there for you. Also, if you need more examples, scrounge YouTube. There's a bunch of stuff on trigonometry, I guarantee you, okay? Just type in trigonometry, find a short video. There's a teacher going over something or another student. Watch videos to understand how this works. They might also give you something else that you like better, some different tips or strategies. But this process is always the same. Bring this foldable to class, and we will have some practice. Thanks, guys.